streaming and hit refresh again. So I think we should be live now, and I'm going to get this link. So we are live, viewing live, control room, and I'm just going to share this link. So I'm just going to copy the link and post it out on social media. Live link to calculating E in Python. PY Python. And I'm just pasting that link in. Of E in Python. There we go. Put a little hash there at the end of it. And so this is our link, and basically what we're going to do is, I've just called it mathematics, a measure of E, and we're going to do this in Python, and it's just something actually that popped up on social media. So I thought, you know what, I'll give it a go. It looks quite interesting. I'm going to do this completely live. I might crash and burn, but I do have a tiny bit of support here. At least I have some old Python code as well that I might be able to replicate and use. So what actually are we going to do here? And basically the statement is, and we can decide if this is true or not, but select numbers between 0 and 1 randomly until a sum is greater than 1. So we need in some way basically to select numbers until and keep on adding these numbers up until the sum is greater than 1. I suppose like the first thing that comes to mind is we can use Python lists. Maybe we can become a bit more efficient, but a list might be more than satisfactory to doing it. And then it says the expected number of selections needed is equal to pi. And I imagine that this is actually the, well, not just the expected, but the measured average. So the measured average is kind of like, I believe, what it should be. And I think backticks might be the right way to do that. I don't know if yeah, okay, so I'm just going to call it the measured average, because we're going to like measure some kind of average of the numbers, because if it was just like, well, that's the expectation basically. So the first thing to do, and I'm just using a Jupyter notebook in Visual Studio Code, but you could actually write the code, you could write code yourself like this in regular Python if you wanted to. I'm just going to do it with Notebook because it's convenient for the purpose of this video. So let's just do our first thing, which is import random, and that's kind of like, I guess, the best way of importing random, of getting random numbers into Python. There are other ways of doing it. I actually did pull it up on Claude AI, like different ways, but import random seemed to be kind of like the predominant one. There is a sequence module, and you can do a seed to get repeatable things, but we want it to be random, not seeded. So we import random, and then basically I guess we want to set some sort of number for like number of loops. So we can say that n equals, I don't know, let's just start with 100, not to do too many loops. And what we're going to do then, we're going to, I suppose we're just going to get a random number in some kind of loop. So let's just do that. So we can say that our random number, so let's just do for I in range, and then n will be our, so we can do it 100 times, and then something like our random number, so random number is equal to random dot rand dot random, like that. And I believe if we do that, yeah, we do here, so it says it anyway, what comes back as a float, and we get a number between 0 to 1, so that's perfect because we don't have to divide down or anything like that. I could have used rand int was the alternative, so I could have done rand int over here, but then I would have had to gone like 0 to 100 and then divided that number by like 100 to get it all back down to a maximum of 1 basically. But let's just do random.random then. Oops, so we just take the top one because that's quite convenient for us. So that's our random number. But then we need to do a check that's basically, I wonder, we're going to have to break out of the loop in some way. So the random sum, so we could say that random sum is equal to, is actually just going to increment by itself, plus equals 1. Right, we're going to increment it by 1, I believe. Is that the right way of doing it? We have to actually set it here. Let's do our initialization. So before we start, we're going to need a random sum to be equal to 0 to start with. And I'm just going to hit close here. And I'm going to do test as well, just in case anyone's watching. No one's watching at the moment. This is still all live. So our random sum plus equals 1. We're going to increment by 1 basically every time that we count another number. I wonder even if we have to do that, because actually, oh yeah, we do. So fine range, okay. We're going to want to increment our number each time, but then we're going to be restarting the loops. So we're probably going to have a while loop inside the for loop. So we're actually going to have a loop then with a loop nested in it. So while, and then I'm going to just call it S for sum at the moment, is less than or equal to 1. So that's probably more like the condition that we're going to do. And we're going to say that S equals 0, otherwise it won't be defined. So we have to start it here. But actually, I'm going to take that out of here and do that, put that in here. So that's our sum now. So I'm going to get rid of this bit at the moment. And we're going to say that S is incremented by random dot random. So we're going to increase our value of S. Now it starts off at 0, and then it's going to get whatever this random number is. So by way of example, if I can open up something like, I've got one of these open somewhere, where is it? New, there we go, we'll just don't save. Right, so we start off at our number, and let's say we start off at number, oops, we're going to start off at 0 because that's our initial point. Basically, we're going to generate this random number, and let's say our random number is 0.15. What we want to do is just add this number on. So I didn't actually move this correctly. Let's just get this kind of like in line. So say we got 0.15. That's what we've got, and then we're going to like top this up. So 0 plus 0.15 is just 0.15, and then let's say we pulled up another random number and it was, I don't know, 0.25. So the next one here is 0.25, like that. So now we're going to have like a cumulative total. So our cumulative, these are our actual random numbers over here. So these things here are, let me just, I'm going to just move all of this across a little bit. So these things here are actually our random numbers. I'll put them over here, and this is the cumulative just down below. This is a cumulative random number. So we're sort of like adding them up. Random number, like that, just like that. And the first one's going to start off as a 0 because it's going to follow it. Then the next one's going to be the 0.15 because 0 plus 0.15 0.15. We'll see, you'll see the pattern kind of like emerge from here. And then afterwards we're going to have 0.15, but then we're going to add on a quarter, so it's going to be 0.40. And that's the cumulative version of it. So I hope that makes sense at least. So let's just move that kind of like in line over here, and that one up there. So that's basically our cumulative version. And like, just by way of very simple example, if the next one here was 0.1, so if I just move that into place, then when we add, there we go, when we add 0.1 onto our series, our cumulative version will go down here and it will be 0.5. So that's basically what we're trying to attempt to do in the loop, and I just stick that over there. So that's all like the cumulative, and we're going to do this until basically we're going to keep selecting these random numbers above until ... we're going to get to 1, or at least greater than or equal to 1. So that's kind of like what we're seeking. We're going to just keep on doing this process of randomly selecting numbers until we get to 1. So I guess if we selected now something like 0.6, we'd have breached 1, so we're going to count just below it. And guess I'd see what happens. I don't even know what's going to happen at this point. So let's just go on and do that then. So we're going to increase S from 0. So we're starting from our originating point. I'm going to make a little circle here, if I can do an empty circle. Don't know if I can. But we are, does that one, going to do shape outline, shape fill. Yeah, no fill, perfect. So we're going to start from here, and we're kind of like going to hop over to our next number. I don't know if I've got some arrows or lines or something, but we're still like going to hop over to our next number, if I can do that. There's the hop, and then again we're going to hop to our amazing hop, and then we're going to hop over to our next number just like that, and hop over. Okay, fine, and then again hop over to our next number like this. So we're just going to keep hopping number to number, and we're going to add up this cumulative as we do that, going across ways. So let's just get our cumulative. We're going to go, we're going that way in direction. So something like that. We're going this direction. So that's basically it in baby drawing language. That's what we're trying to do in Python. We start here and we're accumulating up. So S equals S plus random.random, and that's adding, we see here, a number between 0 and 1. And then we need to do some kind of check, I believe. So it's going to be something like if S is greater than, well, actually, so we're just going to break out of the loop. So that should actually be sufficient at that point in time. S equals 0, and also then we want some sort of counter, I guess. So counter, well, we'll call it S equals 0. This is quite Pythonic, so S and counter are both equal to 0 and 0. So that should be fine. And then our counter is going to be, I guess it's going to be plus equals 1 as well. We're going to increment our counter by 1, and let's just stop there for a minute and just see what happens. Right, we're going to do this 100 times. Let's just do this one time. When we've finished our loop, while S is less than or equal, so we're going to break out of the loop. Let's just here print counter, and also for the sake of it, we'll just print out S, and we're hoping, well, not hoping, this loop is going to continue until S is greater than 1, so we should see a number greater than 1, and we should also see the counter that's associated with it. And that's going to happen 100 times, but let's just do it 10 times to start with. So we run our piece of code, and this is a nice thing about doing it in the notebook, is that we can like run our code live and see it. And what we see already is these are all of the breaches. So we've got to 1.5, 1.18, 1.21, and so forth. Even 1.01 there, so we're just a tiny bit above 1, it broke out of the loop. So it looks like it's working. But also we've got our counter value over here. So I'll actually put this into an F string just because it's convenient. So I might as well showcase all the bits of Python, which is something like, if we do that, if we do counter equals, it looks quite nice like that. And actually, and then put a comma, because I can do the same for S equals. It's a nice little trick. I've never really used it before until this video. So running it like that, and we can see that our counter here, we've got a different set of numbers, but basically 4, 5, and so forth. But what we want to do now is, instead of printing out the counter in S, is we want to top these counters up and then get an average of them over the 10. Now it's looking quite good because we know our number in Python, and I can actually do this anyway. So go here and do import math. So we'll take out the math module down there, import math, and then we can do math.e. And I think that should be sufficient. If we run it, we get the 2.718 because that's the value of E, and lo and behold, all of our values look like, hopefully, we're going to average around that, and that's just eyeballing it straight away. So what we want to do is we want to sum our counters now. So outside of the loop, we're going to say that our counter sum, so I'm going to call it sum count, something like that, is incremented. Oh, we could put it into an array, I guess, even actually. Counter plus it. I'm just trying to think of if we put it into an array, we can do an average of the array. If we don't put it into an array and just do a sum, then we'd have to divide it by the original value of n to get the average. Both of them are going to work. I'm going to start off with just doing the sum then. So sum count. Again, this one here is going to have to, before the loop, be initialized to the value of 0 to start with. And then we're going to do a sum count, again incrementing it. So we're going to increment it, sum count just plus equals. We're going to increment it by its own value. So basically, I think we can just increment it by itself. So each time we're just going to add onto the original sum count itself. Now, I guess could we say sum count equals sum count plus 0? I think that should be sufficient. Yeah, that should be sufficient to increment the number by itself. And just to test that on ourselves, I guess we could go into we could actually just do this as well, just have a little look quickly, which is sum count equals there, like that. I'll stick a little comma in there because it's convenient, and just run that. And okay, that's not looking so good because hold on, sum count, right. We're going to increment it by the counter. Right, there we go, because we've counted up a certain number of numbers. That's what I was, in my head, confused with. Okay, fine. So sum count is going to be incremented by this counter, and then we should be able to print out, and we'll get more than zeros now at least. So let's just do that. And I'm just wondering here why we get to that value there, because are we not that might have to be, I wonder if that's outside of the loop. So oh no, that should be fine, because we're just increasing and increasing, and we're going to do. So that's perfectly fine. This works exactly as we wanted it to, because we're increasing our counts all the time, and then when we come out of the loop, finally, we are going to get our value of E. So we can say that E is equal to sum underscore count, and then divided by however many times that we chose to do the loop iteration for. So something like this, which is not 10, but actually n in our particular case. And then I can do a print, I think, of just effectively, I guess we could do, we'll do another f string in fact. So we'll quotation it here and do F, and then we'll say that this is E, and that's going to, we're calling this our value of E. Now, I don't know if we're going to be like 1 too high, but we'll discover this. But this looks quite good, because we got 26 and we're going to divide it by 10, and that's 2.6, and that's close to our value of E. That was only 10 numbers. Hopefully when we do it for bigger values of n, so if we try and do it for like 100, 1,000, a million of them, we might get closer to that. But I'm just wondering if we're always going to be like 1 below. I'm just having a little think about that, because when we've breached it, we stop, but we haven't counted the number. And also remembering that if we start from 0, we have to, if we start our counter from 0 here, is the one question is our first item, is our first index over there, is it 1? That's the only thing that I'm trying to think about, but I don't think it is. So let's go ahead and try and do this and run it, and like that, and we get well, we've got E is 3.1, and the 3.1 comes from this 31 over here. So kind of like all that's happening at the moment is whatever our total count is. So we had a 2, a 4, 7, and so forth. So we kept, we jumped up by a 2, we jumped up by a 3 here, we jumped up by a 2, we jumped up by another 2 here, by another 2 here, and then from 30, that's a big jump. We jumped up by a huge number. Everything, so we got 21 over there, then 3, because 13 to 21 is like that. That's like a 3 sigma event in there. But anyway, we finally got to 31, and then we had to do 31 divided by this 10 here, and that's where this 3.1 has come out from. So I'm going to now we'll get rid of our code stuff there, and then we're going to comment this line out, because we don't want to have too much of that. But what we're actually going to do now, I guess, is just try this for 100 and run it again. And we get 2.71, so that's looking quite good. Let's just try it for 1,000 and run it, and we got 2.732. And we can keep on running this code. You can see we get 2.715 and so forth. And we can keep on increasing the number of zeros, and in Python it's quite nice because you can do that. So I can go to 10,000 visually quite cleanly and run it again, and we get this. And remember, we're trying to, this is what E actually is, which is 2.718, and so it's looking actually quite good, to be fair. And I imagine that the more of these that we do, the closer that we kind of like get to it. Like these. Remember that this is just an average of random numbers, so we're never going to get exactly that, but we're certainly going to iterate towards it. And I can keep on adding zeros. So now we've done 1,000,000 loops over here, and it's taken a second, but we get 2.7179. And if we try and run again, possibly again, we're getting 2.719. So it's looking very, very accurate. And we could measure our difference from E, which is basically, if we take this import math over here just to test it out even further, and paste it into here, we can get our value of E, and then we can get the error, comma, the difference is, and then we can do E, and then minus math dot E at the end of it, like that, and that's going to be our difference. And actually, I wonder if I can put an equals after that. I don't know if this equals will fail or not. So let's have a look at that. Run it, and yeah, we do. Okay, fine. It's a little bit ugly, so actually we won't actually put the equals bit there, and we'll just get our we'll just print out the result there, and we can see that we get this tiny little difference between them. It's like fractional now. We're within, this is 0.00001. Now that's not always going to be that accurate, but if we do it again, I guess over here, again we get 0.001, so it's pretty damn accurate already, and we've just done a million loops there in Python. So again, 0.0006 over there, and if we, I guess, do something nice, I think we can format it here like this. I think the formatting is like that, which is to 2 decimal places. So let's run it again. We just don't get so many decimals afterwards. Sometimes we'll get a negative where our number's gone just below, and other times we'll get a positive. And that should pretty much be it, actually. So it looks like this statement over here, at least doing it mathematically in Python, I could do 10 million loops. This took 1 second, so it's going to cost us 10 seconds. This isn't the fastest way of doing it by any means. So by all means, suggest like quicker ways, like, you know, like using NumPy arrays might be a hell of a lot faster. So here, if I run it now, it's going to cost 10 seconds of time, maybe even more. We can see the timer going off, but we should get a much more accurate value, at least over there when we do it. There we go. And again, so like, you know, we get this 2.718, and we've got 2.718. So we've got 2.71818 over there, and here we've got 2.71828. So it's pretty damn accurate doing that. I'll just write it one more time for the sake of it. 5, 6, 7, 8, 9, 10. Python's notoriously slow, but that's because I'm using, well, actually I'm not using lists, but I am. I don't know if this is the most efficient way of doing it. I have to think about that to get it in that more efficient way. But again, we got 2.7185, so it's looking like this statement here is actually correct, which is if we select numbers between 0 and 1 randomly until we get a number that's greater than 1, the expected number of selections needed is equal to E. And it's looking like that. I wonder if the counting, again, post it in the comments, should I have started the counter from 1, so stopped 1 earlier, as in we wanted to be 1 underneath it or not. I don't know the answer to that, but that is looking quite good in Python. So I think we'll stop there. That's a great little small, I guess, education use case for some code. I'll run it one more time when I'm finishing. But if you did like this video, if you've got any comments, definitely leave comments in the comments section. If you've got any, if you like the video, hit the thumbs up button, the like button, and the follow button. And even if you don't like the video, still hit the thumbs up button, the like button, and the follow button. And that's basically it. I think I'm going to end the stream and sign off. So that's mathematics and a measure of E in Python.